Good morning, good afternoon, good evening, wherever you may be, and welcome to today's webinar. I'd like to welcome my co-presenter, Andy Bowie, Senior Consultant at Magic Software Enterprises. Welcome, Andy. Andy may have his mic muted, but Andy's out there, and he's going to be joining us later with a live demonstration. My name is Glenn Johnson. I'm a Senior Vice President here at Magic Software Enterprises, and I want to thank you for joining us. Let's go ahead and get started. And I do want to make sure that you are hearing my audio. Yes, you seem to be hearing it, so I think we're going to proceed. Once again, thanks for joining us. The topic today is an important one to many of you, Magic Mobile Apps for IoT Sensors and Controls. We will include a brief webinar and a live demonstration in today's presentation. So we're looking forward to going over just a few preliminary items. First, a bit about Magic. We were founded in 1983. We're traded publicly on the NASDAQ exchange under the ticker symbol MGIC. So we're an open book. You can learn a lot about Magic Software as a global company providing application and development and integration solutions. We've been fortunate with the results from 2015 showing $176 million in revenue, more than 1,300 employees around the globe, some 24 global offices. We have customers in over 50 countries worldwide and in excess of 3,500 global business partners who combined with Magic are supporting millions of users worldwide on application systems and systems that are integrated utilizing Magic's technology. So we'll talk, as we just did, a little bit about Magic. That's it. The pain's over. Now we are going to go on to a brief intro to the Internet of Things and defining that. A little bit about MQTT, which is one of the technologies that you'll see demonstrated today, and the unified development and integration platform that Magic provides to bring all this together. And then, as I said, we'll have that live demonstration. So just a few preliminary words. I think you're here because you've heard of Internet of Things. Obviously, it's a big topic. And we're really just talking about the internetworking of connected devices and sensors. These can be connected to each other, to the cloud, to various controllers. So sensor networks, controlling of specific devices, the various communications that take place are all things that working together comprise the Internet of Things, or IoT. And so these things that are communicating typically across some type of network, it could be wired, it could be wireless. The wireless networks we'll talk about specifically are becoming very key and important players in the system. Then the Internet obviously is a part of the architecture, or else it wouldn't be called the Internet of Things. And so there's a great deal of communication and reporting of data and live events and triggers and things that are happening across the Internet, and all connecting, hopefully, in the back end to some kind of environment. The services environment could include various servers. These could be sensor network servers. They could be integration servers on the back end. And you have various devices connected via the Internet that provide user access and control. We'll be talking a lot about mobile devices and mobile apps today in our session, obviously, for control of Internet of Things. And then, on the back end, all of the business applications, the data analysis, it creates lots of metadata, lots of data, and things that need to be monetized and so forth. So in a nutshell, that might be what the architecture would look like across the Internet of Things. What is it used for? Well, according to the available data on LinkedIn, on Twitter, on Internet searches through Google, one sees that at least the popularity of IoT is in these areas around smart home, wearables, smart city. Magic has been quite involved in that. Smart grid, industrial internet, connected car applications, connected vehicle applications, connected health, smart retail, supply chain, agricultural applications, food processing applications, and of course it goes on and on. But this, according to what's happening on the internet in terms of searches and tweets and LinkedIn activity would seem to be the area where most of the interest lies today in Internet of Things uses. And so many of these may affect your organization. And all of these things can impact business, but especially some of the ones that are probably less popular. Smart home isn't necessarily a direct impact on your business unless that happens to be the business you're in. But in the case of wearables, maybe that would impact your business because it may actually not be a consumer use, but actual business use of wearable activity, whether it be for tracking, for enhanced augmented reality, and so on. So there are a number of applications here that are very, very important across various industries, many of which need to be monetized, tracked, and many of which need to trigger responses from businesses, service calls, and so on. So the Internet of Things remains very popular and creates this demand for the various applications. So how do we do this? With wireless sensor networks, for example, we talked about that architecture where the network is a part of it. Wireless sensor networks are making this more popular and practical because you don't have to wire up all the devices together through traditional, cabling and so forth. You can use wireless to make these connections. And when you do that, then there's typically some kind of a gateway or a wireless, router controller network of some kind that's connecting either to a local area network and certainly to the internet, possibly both. And so that is a big piece of what's driving the popularity and demand is this newer form of networking, that is being used applied in a way that's connecting to IoT. So the back-end integration use cases are many. As you use IoT in the arena of product development, you can actually monitor your products in the field, get real-time feedback, which can help in a product lifecycle management context. You can see when particular pieces of equipment are being taken out of commission, when maintenance cycles are taking place, the popularity and the usage factors for various devices and products that you have in the field that are IoT enabled in some way. So very useful, interesting kind of information where you can have sort of feedback loops to product development based on actual use by the users in the field. And it's really a kind of unprecedented capability when you think about it. We used to do surveys and, how many times do you use your dishwasher every month? Well, now your dishwasher can tell the manufacturer how many times it's being used. You don't have to guess at these things or rely on recollections, which may or may not be accurate. So there's some really amazing possibilities in PLM, ERP, MRP, the operations, manufacturing, financial side of things, obviously the monetization of Internet of Things, so that as people are using devices, as you can actually charge for that. And people are implementing IoT presumably to further their organizational goals, and many of the organizations that are doing this are profit-oriented or that at least need to recover costs. And so monetization is going to be an ongoing need and demand, and the integration back to traditional ERP systems is key. Field service management and customer support systems need to be aware of what's happening via the Internet of Things. A lot of information and operational technology can be connecting to a wide variety of applications. Many of these are proprietary legacy applications as well as some off-the-shelf applications. Customer interfacing controls, web pages that all interact with the customer experience. So you may have customer self-service, apps that allow you to access the Internet of Things, and then CRM-oriented types of applications. When we add mobile into the picture, all of these things then become more than just the back-end enterprise systems, but then the need for new customer-facing apps that interface with that Internet of Things. So how do we do this? One of the great ways to control devices is through a protocol known as MQTT. It used to have a longer name, MQ Telemetry Transport. Now the official condensed name, MQTT. It's a lightweight protocol that works over the TCP transmission protocol, and you basically have MQTT server brokers which act as subscribers and publishers of data. And so this allows for things called topics, and the MQTT supports TLS 1.2. So you have publishers and subscribers to specific topics that are of interest to them, and those topics and publishers of the topics, subscribers to the topics, which are relevant and then can be integrated into backend systems, into mobile apps, controlled via them, etc. What MQTT allows is for the decoupling of producers and consumers in IoT in general, so that you can have a brokering of these communications via technology like the Magic Integration Platform, and you can have mobile interfaces to control these, or desktop interfaces to control these via the Magic Application Platform. So sensor networks that are being used for a wide variety of sensing capabilities, microphones, light or photoresistor sensors, the radiation detectors, heat detectors, humidity detectors, all kinds of shock connectors, and so on and so forth. Tilt orientation, things of this nature. So these sensors can provide vital information to users. The United States Army has been using sensor networks for a long time in the transport of food to our troops. And so these various sensors then are connected via RFID, and they sit inside of those containers, and they know that the container has or has not been tampered with before it even arrives to the dock. They can sense whether or not a door has been opened, and so on and so forth. So all very, very valuable in different applications and settings. So these are part of the external trends. IoT is a part of the external trends that are driving integration across the enterprise. And so we're going to look specifically at IoT today, but it fits in to a lot of pressures that we know IT departments are facing, developers are facing, for mobile apps to integrate to the cloud, to really be involved in a number of needs for innovation in the enterprise, the whole PLM revolution in the enterprise today, customer experiences driving integration needs, the need for global 24/7 services, self-service capabilities, and social networks. But IoT is one that is exciting, and we're going to look at specifically in today's session as it fits into the overall integration requirements for your enterprise. Now, what does Magic offer in this regard, so that you understand why we're talking about this? The Magic XPA application server and the Magic XPI integration platform are key elements of a very unified development and integration solution for creating a mobile app controlled IoT environment for your enterprise that is integrated to your back-end system so that you can capture data information, trigger and control things in real time. So that, I think, is very exciting, and that's what we're going to look at right now. So what I'd like to do is hand control of the webinar over to Andy. And Andy, you should have control now, so as soon as we see your desktop, I'll let you know so that you can begin your demonstration.
All right. Perfect. Thank you very much.
Thank you.
And then also, just to make sure that you can see my screen, Glenn, if you can also make sure that we can see the webcam as well.
I can see live into your office. That is so cool. So now I see a mobile app, and I see your office. Now I see the whole desktop again. Okay, got it.
Give me 1 second, all right. I have two webcams set up today, and the first one that I wanted to go ahead and park on is this webcam here. Give me 1 second. And as Glenn had mentioned today, one of the main focuses we're going to be going over is IoT with our Magic XPA and XPI solutions and how we can add business values to our solutions in place today. In today's demonstration, what I'm going to be going over are three main parts. The first part is our live demonstration, where I'll be walking you through a mobile application and how we added IoT to further extend this mobile application's functionality. And then after that, we'll go ahead and jump into our two products, Magic XPA, and how we develop the front end. XPA is our application development platform. And then the last part is where we'll go over Magic XPI, which is our integration development platform. Before I go ahead and continue, Glenn, I just wanted to verify with you. It looks like I'm only showing one at a time. Let me know if that's correct. But here I'm trying to go ahead and show you my webcam and my screen as well. Are you only seeing one at this point?
I see the webcam with the sensor controller off to the left, and then I see a mobile app with your brightly colored Google screen there that you're moving around in the middle, and then behind that I see Magic XPI, it looks like. Yes. So it looks like I'm seeing all three elements at different times as you're highlighting them. Now the mobile app just went away. Also, your microphone is just a little bit weak, so you might want to try to position that closer if you can.
Go ahead and try and change that. Give me 1 second here. All right, how am I doing now?
That sounds better.
Okay, perfect. Okay, so we'll go ahead and dive into the demonstration. All right. So what I'm pulling up on the screen here is our a work order management application that we developed. This is just a simple work order management application where technicians would go in, perform some kind of labor or labor on a piece of equipment. Again, going into your use cases, Glenn, one of them was equipment management. Okay. Now this existing application here is integrated with JDE. So here we have Magic XPA, which is the application you're seeing on your front end, and we are using Magic XPA to communicate with our integration platform, where it's actually adding and managing these work orders inside of JDE. So that's why right now you see on the front here you have a mobile device, and on the back end you have JDE. Okay. What you're seeing on the screen here is actual physical device. I'm simply using Movizen to display it. And what I'm going to go ahead and do here is I'm going to go ahead and select Add Work Order. All right. So I'm going to go through this demonstration a couple times, and I'm just going to create a quick work order, and we'll go ahead and call this Webinar Test 1. Okay. And when I go ahead and click Save, it's going to go ahead and create this work order and create it inside of JDE. So once it's created, I'm going to go ahead and jump over to my JDE background, and we'll see that this work order was created. Okay, so if I go ahead and perform a search, and we have from most recent to latest work orders, and here we see our Webinar Test 1. All right, so pretty straightforward work order management application, right? I'm sure if you've been to any of our mobile webinars before, you've seen a demonstration similar to this, where we use XPI to go ahead and use our JDE connector or whatever our application connector is to perform whatever functionality required, whether it's creating work orders, creating new contacts, accounts, or leads, and whether it's a CRM, PLM, or ERP endpoint that you are looking to integrate with. All right, so everything comes pretty standard here. Now what I'm going to go ahead and do now is show, again, the focus of this webinar here today is to go over IoT. Now under the webcam, what you're seeing on your screen under the webcam is an Arduino chipboard. And this is our IoT device. It's connected to a power grid, in which we are actually connecting this power grid to some quote-unquote service lights. Okay. I'm going to go ahead and switch the webcam over to my second webcam here, and you'll go ahead and see that this is my makeshift server room. Oh, give me 1 second. Switching to the new webcam. All right. So here, as you can see, we have a makeshift server room, and on top of the quote-unquote servers, you'll see maintenance lights. Okay, and this is how we're adding business values to our existing system, right? Before we introduced IoT to the solution here, we simply had an application that said, basically told the technician that a server required maintenance, and A work order was created for that piece of equipment. A technician will come into the server room, perform whatever maintenance on that piece of equipment, and then close out the work order. And as far as you know, that's it for the solution. However, by adding IoT to using IoT devices with this solution in place, we can add a little bit more of an interface, or more infrastructure management to the equipment itself. As you can see, the light is actually on one of my servers right now. So what I'm going to do here is I'm going to go back into my application, and I'm going to go into that work order that I created here. And I'm going to go ahead and close out this work order. Again, the whole business use case being I'm a technician. I came in, performed maintenance on whichever machine required maintenance, aka the one with the light. And I performed the maintenance. The machine's up and running now, so I'll go ahead and close out this work order. And then we should go ahead and see that the maintenance light is turned off. Give me 1 second here. All right, so the light goes off. All right, and then again, we'll go back over to our JDE backend, and we'll see that the maintenance, that the work order has been closed out. And if I pull up my mobile application here again, we'll see that the work order is no longer in our work order list screen because the work order has been completed. All right, so just to reiterate, we'll go through this one more time. Again, the idea of this demonstration here is to show you that we had an existing work order management application and how we how we utilized IoT lights to help further help our technicians to visually see which pieces of equipment required maintenance and which pieces of equipment were quote-unquote out of commission. Right. So I'll go ahead and create a new one. I did booth 1 before. I'll go ahead and choose booth 2, and we'll call this webinar test 2. Okay. I'll go ahead and save. And then if you pay attention to the webcam, it goes ahead and turns on that maintenance light on the other machine. Over on the screen sharing or on my desktop, I'll go ahead and refresh this, and we'll see that our webinar test 2 work order has come in to JDE. All right. And then lastly, just to close things off, I'm going to go ahead and close this work order. All right, and there you go. Okay, so that concludes the live demonstration. Now what I wanted to go ahead and do is briefly go through the back end and show you exactly what is happening here. All right, give me 1 second to put my mouse back in here. Okay. Now, where I wanted to go first is our Magic XPA platform. Again, XPA is our application development platform, and this is the front end or the interface that you saw on the mobile device, right? With XPA, it gives the Magic XPA Studio, which is what you're seeing here on your screen now, is what the developer will use in order to develop their application. Now, one thing I want to mention is that I say to develop applications, that it's to develop the application and not necessarily the mobile application. For those of you that are not familiar with Magic XPA and its application architecture, what we're creating and what we're installing onto these mobile devices or these machines or these devices is what we call a true client application. And what that means here is that on these what you're installing onto your device, all that's being stored in those application installers is where's my application server located and what application to execute on that application server. The actual screens, the metadata, the buttons, the logic that's coded into the application, this is all handled by the XPA server. So basically, you're instructing your devices on how to connect to the machine. The benefit of abiding by this architecture is that it allows us to achieve deploy throughout many platforms, right? Cross-platform deployment. Okay. So when we're creating these application installers, we're actually just creating a light client that's installed onto our Android devices, onto our iOS devices, or even onto our Windows desktop. Okay. So here on the screen, in the Magic XPA Studio, there's several repositories. We have our data repository and our programs repository specifically. The data repository is where we designate which databases or data sources we're going to connect to, and the programs are basically methods or interfaces. So I'm going to go ahead and zoom into our list. This is the first screen we saw here. And I'll go ahead and jump into our form editor. And as you can kind of infer from the name, the form editor is the interface development screen. Now with the new version of XPA 3.1, It's actually powered by Visual Studio, and it gives us a lot of features that we didn't have in previous versions. One of the main features here is the mobile form previewer. So any changes that I make to my application, for instance, if I extend this button here, we can see that what the button change will look like according to our devices, right? So if I change this to an iPad mini, we'll see that the device gets cut off at the bottom. So that means I have to make changes to my interface, for instance, all right? Basically, what the benefit of this is to help you with the developing your application, and what you see is what you get. So when it comes time for deployment, you don't have to make any micro adjustments and keep redeploying your application. Now, without going too much further into this, going over the methodology of Magic XPA is that it is an event-driven language. So for instance, when I click this Add Work Order screen, it raises a user-defined event called Add. Jumping over to my Logic tab, and this is where I create the event handler. We'll have our event Add, and that calls our new program or another method, Work Order New. Okay, so if I jump over to that program, we'll see that, and I jump into the interface, we'll see that we have that screen where it allowed me to create a new work order. Now, last thing I want to get into with Magic XPA before I jump over to XPI is this last event here. We have our user event, the button Save, which raises user event Next. And what that actually does is Next performs an HTTP post, which calls our XPI integration project. And that will be our segue going into Magic XPI. Okay. Now, before I jump into XPI to finish off XPA, going over deployment, because that's an issue that a lot of developers are running into when it comes to creating these application installers. In general, Magic XPA has a wizard that ties this all together in one easy wizard for us to go ahead and deploy our applications in one shot, basically. So here we have our rich client deployment wizard. And basically what we do under this rich client deployment wizard is we designate and define the configurations for these applications that get installed onto the devices. Again, referring back to the true client application. The only information that's being stored on these devices, again, is how to connect to my application server. And once connected to that application server, what application am I, quote unquote, executing or showing on the user's or client's screen. So on this first screen of the wizard here, I just have the application details, what the name of the application is to display, and other information such as description, which we'll see during the installation screen. Next, I have my server information. Again, this is how I connect to my development server, right? Or not, sorry, not my development server, but my application server. After designating how to connect to the application server, we have the screen that designates us how to go ahead and what application to execute on that server and what program to pull up first, right? So if I have a login screen, of course I'm going to want to put the login screen up first. So that's what I would put under that second field. All right. Next is the main screen that I wanted to show you, and it is the Android and iOS or the platform configuration screen. Here I can designate which operating systems I want to deploy this application to. So for instance, if I choose Android, what it's going to prompt me for is my Android SDK folder. Now when we're creating these application installers, we're using the native SDKs of the whichever platform we're deploying to. This maintains several things for us, right? We can maintain the native look and feel of our application, and also it allows us to call any APIs or any features of the device itself, such as camera, such as GPS location, even querying information such as what version of the operating system this application is being executed on, what the screen size is, what the pixel dimensions are, for instance. And as you can see, by having access to this information or access to these features, it allows us to extend the functionality of our applications, whether it's taking pictures of the camera, whether it's pulling files from the device itself, or whether it's using GPS to track where the application is, right? For instance, one case is where when I take an image, I can pull that current GPS location of the device when that image was taken. So after this screen, after I designate the Android, where the Android SDK is located, it will actually output me the APK, which is the application installer file for Android. If I jump back to iOS, it'll prompt me for my provisioning profile and the developer name. And what this will output to me is an Xcode project. Again, Xcode is the iOS native SDK, and by giving me this Xcode project, it will allow me to generate an IPA which gets installed onto my iOS device. Okay, so that's how Magic XPA handles develop once, deploy many times methodology, right? Again, we're only installing something light onto the device itself, and it's actually the server that's handling the bulk of the work. All right, so that concludes for XPA. Now we'll go over into XPI. Just to kind of review, we click that Save button on the new work order screen, and when we click Save, it calls a flow inside of our XPI project. What you're seeing now on the XPI on your screen is our XPI Studio. And with the new version of XPI 4.5, it got an interface revamp. It's now powered by Visual Studio as well, which gives the developer many options and cuts development time immensely. Okay. Just to kind of show you, basically, again, XPI is our integration platform, and what this does is this takes on your whichever business process you want to implement and creates integration to integrate any applications you have and to manage data transfer. Right. When it comes to what I mean by business or by your business process, right? For instance, there's business processes where if you want to create an order with a specific contact, but that contact does not have an account associated with it, then we might want to create that account, right? So instead of it's not just taking data from point A to point B, but also ensuring that any microtransactions that need to occur around it are in fact occurring. Okay. So here we have our flow component steps, and basically it's a drag, drop, and configure interface. And just to quickly go over on a high-level view here, again, this application that we had prior to implementing any IoT functionality onto it was simply to take in a work order and create it in JDE. So here we have a step where we have an HTTP service where our mobile application called it and passed it some information, and we have our JDE steps here where inside of JDE it begins to document, creates the work order in JDE, and then ends it. Okay. When it comes to XPI, how do we handle the connection to JDE? Okay. Of course, when we're working with integration in several applications, we need to designate how to connect to those applications, right? And when it comes to XPI, we're doing real-time schema discovery so that it's actually connecting to, in this case, our JDE server and pulling in the schemas to create these work orders. It's pulling in the schemas to create work orders or whichever functionality that you're trying to achieve, right? And under these resources, we simply enter the server name in one centralized location, the environment, the username and password to connect to it, and from here we can go ahead and validate our resource, right? This goes ahead and checks and ensures that we have a valid connection, and as a result can in fact integrate to this application. Now the benefit of having it at one centralized location is for every instance, as you can see here, we have several steps where we call our JDE server. And instead of if the credentials are ever to change or we switch from development to deployment, again, this goes into maintainability, then instead of having to change the credentials in every single step, we have one centralized area. Now the application before simply had this flow on the left, and all we did was create the step in JDE, and that was the end of the integration process or the business process. But now by adding those IoT devices, what we're doing here is we're calling a second flow, and what it's doing here is it is calling our Arduino board, right? And it's doing this through an HTTP post, and it's sending a set of parameters to this board through its own MQTT server, and as a result, it turns on that light for us when it reaches this step. Okay. Again, this HTTP service is defined under as a resource, right? Again, this is something that this integration project is going to connect to, and here's the URL that it is connecting to address that that IoT chip. And as Glenn had mentioned, with the new version of 4.5, XPI has its own MQTT component. See, I'm going to go ahead and drag and drop my step, and it'll allow me to call whichever MQTT server I've defined under my resources, and as a result, I can send a message to the subscription here. All right. So just to kind of review and tie off, the benefit of using IoT in your application is that it's to bridge your devices or bridge devices with recurrent infrastructure, whether that's for data collection, equipment monitoring to allow or control access control, or just for simple infrastructure management. And one of the benefits of implementing IoT devices to your current solution today is that it's a lower power usage, requires minimal processing power. There's a wide range of devices. Here in the demonstration today, we simply used lights. But there's, for instance, for a server room, you may have a thermometer, right, where if the temperature crosses a certain threshold, we could have our Magic XPI project send an email to a specific user to go check on that, or to automatically create a work order, for instance, right? And lastly is the push and subscribe model. We could have several devices subscribed to an MQTT server, and in the event that it receives a specific message, it can handle whatever protocol required. All right, and that basically sums up the XPI demonstration and demonstration overall. Glenn, do you want to go ahead and open up the floor for questioning?
Yes, absolutely. Thank you so much. Great demonstration there, Andy. Really appreciate it. And for all of you online, if you have a question, please enter it into the question box, and we will be happy to get to those questions as they come in, or you can put them into the chat box and send it to us as well. So let's see if there are any questions coming in. We'll give you a moment to enter those in. Large group online today, so we'll give you some time to enter those in. While they're waiting, Andy, maybe I'll just throw in a question. How would you handle this if you needed your mobile app to go into offline mode? How would that work? If you lose connection?
When it comes to offline applications, the methodology here is that all metadata is stored onto the device. So when it comes time for IoT, there will be some kind of sync process, right? Like the offline application will need to check into the server from time to time. So for instance, this application here, we could sync all of the work orders to the device itself. We can create a work order onto the device offline. But when we sync up and need to add the work order back to the server, that sync process could call, one of the steps would be to sync, upload any work orders that are on the device that are not on the server, and then call whichever activate whatever IoT device is necessary.
All right, great. Let's see if we have any more questions coming in here. Yes. Which version of Magic will this is this relevant to?
What we showed here today is version 3.1, XPI 3.1, and XPI 4.5. But in terms of the functionality itself, this is just performing HTTP calls, right? So basically, any of the recent versions of XPA and XPI will suffice. Again, mobile was only introduced in Magic XPA 2.5 and above, so that would be the minimum requirement, I guess, there.
All right. Here's another question. As an XPA developer, do I need to use XPI to connect and communicate with IoT devices, or is functionality available in XPA to communicate? Good question.
The functionality is available in XPA as well. Again, the way that this mobile application in particular was communicating with XPI was through HTTP, an HTTP call, right? The only reason why we added the IoT communication on the XPI step is because that would be relevant to the business process. We wouldn't want to turn on the service light if the work order was not created successfully, right? So that's why we had it there. But in the event that we were just adding to our own kind of a homebrewed backend system as opposed to JDE, then we may handle that all in XPA. So to answer your question, no, you do not need to use XPI to communicate with IoT devices.
Okay. Another one says, interested in new Visual Studio-based form editor. Can the underlying code be edited directly in Visual Studio?
To answer that question, yes, you could edit it manually, but again, we do not recommend manually modifying any of the source code. The studio has its own encryption and its own way of handling the source code, so if you pull up that source code too, it gets quite tedious. So it would be most beneficial and less tedious to handle it through the studio. But yes, you could, since it's Visual Studio based, you could use Visual Studio to manually modify the code.
In theory, that's possible. Okay. Let's see. What else? I don't think I have any more questions. Let me make sure I didn't miss them. Those are all the questions I see at the moment. So I want to thank you again, Andy. Thanks to all of you for joining us. If you have any follow-up questions, please feel free to contact your local Magic branch here in the Americas. You can reach us at info@magicsoftware.com if you want to send an email or give us a call at 949-250-1718. If you dial extension 259, Angela will make sure you get connected to the right person for your follow-up questions. And we do appreciate very much, again, you're joining us on this webinar. For additional webinar information, check out magicsoftware.com and select News and Events, Webinars. See you all later. Thank you.
Thanks all.